Okay, we're going to continue our exploration of exponential functions by looking at logarithms today. If we have these different exponential equations, we can figure out how to solve for y. So if we have y equals 2 to the power of 3, we can just calculate what 2 to the power of 3 is and find the value for y. Or if we have y equals e to the power of 4, we can use our calculators and our e to the x button and find the value for y. We can even find the value for y in an equation like this one, where y equals 1.23 times 3 to the power of x over 2 when x is 12, because we just substitute it in, use our calculators, and we can come up with a value for y. The challenge comes, though, when we want to solve for x in an example like the example number 3 above. When we're solving for the exponent, it's not that easy to figure out how to solve for x. It's very difficult. We can't isolate x without this new tool of using logarithms. So for instance, if we have this example, 8 equals 2 to the power of x, well, we can look at that and we go, well, 2 cubed is equal to 8, so we could say x is equal to 3. But if we have 10 equals 2 to the power of x, and we wanted to find the value of x that made that true, well, we know it's somewhere between 3 and 4 because 10 is between 8 and 16. So we could guess and check, and we could put 3.1 into our calculators and 3.2 into our calculators, and we could go back and forth until we have narrowed in on the value for x that's to the level of precision that we want. Same thing with 53. We could guess and check numbers for x, enter them into the calculator, and see if we're getting 53 for our answer. However, we want a more straightforward method rather than guess and check. We need to learn how to use logarithms. And this is what logarithms look like. If we have this exponential equation where y equals b to the power of x, then we can say that x, so notice we're isolating the exponent here, x is equal to the log of base b of y. So the log base b of y, and log is short for logarithm. Okay? It's really important that you be able to very flexibly go back and forth between the two forms. So if you think about this exponential equation that we looked at already earlier today, 2 to the power of 3 equals 8, we can say then that 3, the exponent, is equal to the log base 2 of 8. Okay, this base number is written as a subscript, so it's which is the opposite of a superscript, so it's down low and it's smaller number, so that shows you the base. So the base of the logarithm is still the base of the exponent, okay? But the exponent now is isolated on one side of the equal sign. So this is logarithmic form and this is exponential form. These both are the same equation. They're both showing the same relationship. So in these next three examples below, you've got three logarithmic equations. Give a try now and convert those to their equivalent exponential form. Okay, so again, remember that the number that's isolated is the exponent. The base of the logarithm is the base. So we can say that 5 squared is equal to x is the exponential form. So in this one, we've got b to the power of 6 equals 64. And in our final example, we have 7 to the power of y equals 3. Okay, we're not calculating the missing variables yet. We're just practicing going back and forth between the two versions. Here we have exponential forms of equations and take a moment and try to rewrite those as in logarithmic form. If you like, this is a good time to press pause, give it a try, and then check it. So in this example, I've got 7 to the power of 2 equals x. So we can say that 2 is equal to the log base 7 of x. A cubed is equal to 64. We can say that 3 is equal to the log base a of 64. And for e to the power of y equals 31, we can say that 31 is equal to, and hopefully you caught that mistake faster than I did, you can say that y is equal to the log base e of 31. Some logarithms we can evaluate by inspection. So that is without needing a calculator or any fancy rules. So this is where being able to switch back and forth between logarithm form and exponential form really comes in handy. So if I want to evaluate this logarithmic expression, the log base 2 of 8, I can think 2 to what power, so I'll call it an x, is equal to 8. So what's the value of x that gives me that? Well, 2 cubed is equal to 8, so the answer to this one is 3. Likewise, for the next one, I can think 7 to what power? 7 to what power gives me 1 over 49? Well, 1 over 49 is 1 over 7 squared. So remember the ideas of reciprocal numbers with exponents. So we can see that x is going to be equal to negative 2 because 7 to the negative 2 gives me 1 over 49. The log base 25 of 5. And don't get tricked here because it's not 5 squared equals 25, but 25 to what power gives us 5. And since 5 is the square root, we can see that the value of x is 1/2, where a square root is equal to the power of 1/2. So the answer to this one is 1/2. And the log of base 2 of the 5th root of 2 means that we've got 2 to what power gives us the 5th root of 2. And remember that the equivalent roots, that would be equivalent to 2 to the 1/5. So the answer here is 1/5. Okay? So it's really important to know all of the rules of exponents in order to be able to simplify these logarithms. Now, a couple of notes about logarithms before we finish. The log of base b, the log base b of b is equal to 1. That makes sense because b to the power of 1 is equal to b. Okay? So we could extend that further and we could say something like the log base b of b squared is going to be 2 since b squared is equal to b squared. The log of base b, so that's really for any base b of 1, is going to be 0 since b to the power of 0 equals 1. So those are two important rules to remember because they make the evaluation of logarithms very quick and simple. When no base is written, or when you don't see a base, the base of 10 is presumed. So when you see log 100, that's actually the log base 10 of 100, which would be 2 because 100 is 10 to the power of 2. And our natural number e happens to have its own special logarithm, which is called the natural logarithm, and it's called ln. So ln of x would be equal to log base e of x. You'll actually never see a log written with the base e, it's always written ln of x. Okay, so it's pronounced ln of x. Okay, so that's an introduction to logarithms.